Welcome to Huberman Lab Essentials, where we revisit past episodes for the most potent and actionable science-based tools for mental health, physical health, and performance. I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. Today's podcast episode is about jet lag, shift work, and we are going to discuss protocols that are backed by science that can support particular tools that you can use to combat things like jet lag, offset some of the negative effects of shift work, and make life easier for the new parent as well as for the newborn child, the adolescent, anyone that wants to sleep better, feel better when they're awake, etc. Let's just take a step back for a moment and remind everybody what we're talking about. The circadian rhythm is a 24-hour rhythm in all sorts of functions. The most prominent one is a rhythm in our feelings of wakefulness and sleepiness. You also have a rhythm in sleepiness and wakefulness that correlates with that. We tend to be sleepy as our temperature is falling, getting lower, and we tend to be more awake or waking when our temperature is increasing. We have a clock over the roof of our mouth, a group of neurons called the suprachiasmatic nucleus. That clock generates a 24-hour rhythm, and that clock is entrained, meaning it is matched to the external light-dark cycle, which is, no surprise, 24 hours. Spinning the Earth takes 24 hours. So our cells, our organs, our wakefulness, our temperature, but also our metabolism, our immune system, our mood, all of that is tethered to the outside light-dark cycle. And if we are living our life in a perfect way where we wake up in the morning and we view sunlight as it crosses the horizon, and then by evening we catch a little sunlight, and then at night we're in complete darkness, we will be more or less perfectly matched to the external or ambient light-dark cycle. Very few of us do that because of these things that we call artificial lights and this other thing that we call life demands. So today we're going to talk about when we get pulled away from that rhythm. So what is the perfect day? What does that look like from a circadian sleep wakefulness standpoint? You basically want to get as much light, ideally sunlight, but as much light into your eyes during the period of each 24-hour cycle when you want to be awake, when you want to be alert. And you want to get as little light into your eyes at the times of that 24-hour cycle when you want to be asleep or drowsy and falling asleep. How much is enough? Well, a good number to shoot for, as a rule of thumb, is to try and get exposure to at least 100,000 lux before 9 a.m. 10 a.m. maybe, but before 9 a.m., assuming you're waking up sometime between 5 and 8 a.m. The mechanism of circadian clock setting involves these neurons in your eye that send electrical signals to this clock above the roof of your mouth, and that system sums, meaning it adds photons. It's a very slow system. So here we're talking about trying to get that at least 100,000 photons, but not all at once. So what do? You go outside. Going outside, even on a cloudy day, could be 7,000, 10,000 lux. It's really remarkable how bright it is, meaning how much photon energy is coming through. So try and get 100,000 lux before that 9 a.m. Now, if you can't do that because you live in an area of the world where it's just not bright enough, some people have sent me pictures from northern England, it's just not bright enough in winter, then sure, you can resort to using artificial lights in order to get enough photons. And I'm putting out this 100,000 lux number as a target to get each day before 9 a.m. You can, in theory, get it all from artificial lights, but there are some special qualities about sunlight that make sunlight the better stimulus. Then I've recommended, based on scientific literature, that you look at sunlight sometime around the time when the sun is setting. And the reason for that, of course, is because it adjusts down the sensitivity of your eyes. Because here's the diabolical thing. While we need a lot of photon energy early in the day to wake up our system and set our circadian clock and prepare us for a good night's sleep 14 to 16 hours later, it takes very little photon energy to reset and shift our clock after 8 p.m. And that's why you want to, as much as you safely can, avoid bright light and even not so bright light between the hours of 10 or 11 p.m. and 4 a.m. So let's talk about shifting clocks, because for the jet lag person, this ability to shift the clock with light, temperature, exercise, and food is vitally important for getting onto the new local schedule. And there's so much out there about jet lag today. I'm going to dial it down to one very specific parameter that all of you can figure out without any technology or devices and can apply for when you travel for work or pleasure or anytime you're jet lagged, and I want to absolutely emphasize that you don't have to travel to get jet lagged. Many of you are jet lagged. You're jet lagged because you're looking at your phone in the middle of the night. You're jet lagged because you're waking up at different times of day. You're jet lagged because your exercise is on a kind of chaotic regime. Some days at this time, some days at that time. But there are some simple things that you can do. So that's where we're headed. Let's talk about what jet lag is. There are quality, peer-reviewed papers showing that jet lag will shorten your life. Jet lag is a serious thing. Now, here's what's interesting. Traveling westward on the globe is always easier than traveling eastward. Okay? It's interesting because the effects of jet lag on longevity have shown that traveling east takes more years off your life than traveling west. Now, here's what's interesting. When we think about the effects of jet lag on longevity, or this idea that it can shorten our lives, we have to ask ourselves why. Like, why is that? And it turns out there's a pretty simple explanation for this. We've talked before about the autonomic nervous system, this set of neurons in our spinal cord and body and brain that regulate our wakefulness and our sleepiness. It turns out that human beings, and probably most species, are better able to activate and stay alert than they are to shut down their nervous system and go to sleep on demand. So if you really have to push and you really have to stay awake, you can do it. You can stay up later. But falling asleep earlier is harder. And that's why traveling east has a number of different features associated with it, that because you're traveling east, you're trying to go to bed earlier. You know, as a Californian, if I go to New York City, I've got to get to bed 3 hours early and wake up 3 hours earlier. Much harder than coming back to California and just staying up a few more hours. And this probably has roots in evolutionary adaptation, where under conditions where we need to suddenly gather up and go, or forage for food, or fight, or do any number of different things, that we can push ourselves through the release of adrenaline and epinephrine to stay awake, whereas being able to slow down and deliberately fall asleep is actually much harder to do. So there's an asymmetry to our autonomic nervous system that plays out in the asymmetry of jet lag. All right, well, let's think about travel and what happens. Let's say you're not going eastward or westward, but you're going north or south. So if you go from, for instance, Washington, D.C. to Santiago, Chile, you're just going north and south. You're not really moving into a different time zone. You're not shifting. So you will experience travel fatigue. And it turns out that jet lag has two elements: travel fatigue and time zone jet lag. Time zone jet lag is simply the inability of local sunlight and local darkness to match to your internal rhythm, this endogenous rhythm that you have. So before we get too complicated and too down in the weeds about this, I want to just throw out a couple important things. First of all, some people suffer from jet lag a lot, other people not so much. Most people experience worse jet lag as they get older. There are reasons for that, because early in life, patterns of melatonin release are very stable and flat, and very high actually in children. Then it becomes cyclic during puberty, meaning it comes on once every 24 hours and turns off once every 24 hours. And then as we get older, the cycles get more disrupted and we become